We are live. We should be live. Yeah, we are
That's
live.
good.
They changed the button positions. So today, playing with logic, programming, and OCaml. I wonder if having a different title will make a difference. Let's see. I bet not, but well, it is what it is. Okay, so
It might.
today is compilation day of L2. So as far as I can tell, I actually have no recollection, but I believe. Yeah, last time we were doing L0, so yeah, so we jumped L1 in the recording because we already implemented L1. And the difference is that L1, the difference between L1 and L0 is that I actually don't remember what is the difference. I think L0 is only one fact, and
Yeah, I think so. Yeah, it was just one thing.
yeah, and then we did this thing, and today we are handling L2, which basically allows us to have bodies in our. What's the name of this again? This is not a fact because this has a body.
This is a predicate.
This is a predicate, yeah, and this is a chain, as far as I remember. Cool. So this is chapter 3 of our reference. So this is this chapter here, flat resolution, and it introduces a couple of functions such as allocate and deallocate, but we implemented that offline last time. So I believe this lives now in the evaluator. Yeah, so here it is, the allocate and deallocate functions.
Yeah, therefore stack management.
Oh yeah, we also should say in the recording, for recording purposes, that the store is now uh, diversified. So now we have, I believe in the recording we already had heap and PDL. Now we have a stack and a code region. So that also happened. And what we are going to be doing today. Today we need to compile this mother flipper. What that mean? What does that mean? We need to go to this example here, and we need to put this inside the computer. We need to
Yeah,
put this
because
inside the computer.
right now we can parse it, but we don't have compilation for this thing yet.
Yeah, yeah. I wonder when we're gonna say, like, because here's the thing, Marinho. We don't know if our implementations of the evaluator work, right? We don't know this for a fact. So at which
Hmm,
point we're gonna say, okay, let's actually stop the L evolutions and try to actually run the evaluator. I wonder when that's gonna happen.
considering this is a book about the virtual machine, I'm not sure if the book will do that. Um,
Probably the book won't, but that's like a personal thing that we should establish.
hmm,
I think L2 is a good point to consider this because this is the point in where the programs kind of get a little bit more real because now we have a body.
I guess that makes sense. Sure, we can try running something after we have compilation for L2.
Yeah, yeah, I think that's gonna be a must because, like, I don't think it's a smart choice for us to implement like a bajillion functions, and we have absolutely no idea at all if they are right, and if they aren't, we're gonna have to put a bunch of prints to know which one of these is wrong.
Yeah,
Especially this one. This one is 99%. Okay, I'm not gonna say 99%, but there's a significant chance that this is wrong. And we're gonna discover this in the best way possible with a crash.
amazing,
Either a crash or an output of the program that doesn't make any sense. So that's
amazing.
cool. Okay, so I already said we implemented allocate and deallocate, and now we're going to implement the compilation. So as far as I recall, we settled that the compilation of L2 is basically a compilation of L1 in sequence. Is that correct?
Uh, kinda, kinda.
Kinda. Okay, what do you mean by kinda?
Uh, Well, there's the detail that translating a body of a predicate is a little different. I mean, it's
Huh.
kind of similar, but it's a little different. In particular, you need to deal with like argument passing between each call, right?
Okay, but how are we gonna do this then?
Let's see. Uh,
Yeah, so facts are carried over from L1 to L2. So the facts so facts are the ones without a body. They're not predicates. So it's the same. Um,
yeah.
cool. And this is true up to a wee detail regarding the proceed instruction. It must be made to continue execution after successfully returning from a call to a fact. Back to wait, are we going to have to introduce calls in the middle of the code? In the middle of the compilation process?
Well, yes.
Well, so that's the first step. We need to go to the machine and define an instruction called call. Oh, it is already here, actually.
It is, in fact, here.
Yeah. Uh, it is translated exactly the same way. So a query is a particular case of a rule in the sense that it is one with no head. It is translated exactly the same way, but with other instructions for the missing head. The idea is to use L1's instructions, treating the head as a fact, and each goal in the body as an L1 query term in sequence. Hmm. Wait, so are we going to pick pieces of the body and wrap them in a query and call it? Is that what we're going to do?
Yeah, we're basically going to say that a body of a predicate is kind of like a query with some extra
What
details.
does it mean to this thing, get arguments? This is not an instruction that we have here.
Well, we do have like get variable and get structure and get value as well, actually.
Yes, we do have those.
And I'm pretty sure we have. um I'm pretty sure the compilation scheme for queries has like emits a sequence of get. Uh,
Wait, but then that's going to be done automatically if you wrap stuff in a query.
but we're not going to wrap stuff in a query. We're just going to emit code in a way that's similar to a query.
Hmm. Okay. So we also
And
need
in
to
fact, this,
protect the registers. I also remember that from last time. How do you
yeah.
plan on doing that?
Well, we need to tweak register allocation because right now we only allocate X registers, which are temporaries, right?
Yeah,
Uh,
let's just start by that. I think I'm being overwhelmed. Let's just start by baby steps. So the first thing that we need to do is to change this guy, right?
yeah.
So we need to
Um,
introduce X registers here, and then have Y registers.
um, yeah, I'm pretty sure we did something similar already in another file, right?
We did in the evaluator and in the machine. Yeah, here we did this.
Yeah.
But these are different sets of registers though. Like this has different semantics. This is mapping a register map. Okay, this is mapping a node of the EST to a number. The other
Yeah.
thing is mapping a different thing.
I'm pretty sure the other thing like actually holds. Huh, I actually forget what it does exactly.
It does this thing. Well, it does. It holds an integer to a value, basically.
Oh,
They,
right. It actually holds the content of the register. That
exactly,
is correct.
exactly. This is just for allocation for our purposes. So what I'm gonna do, I'm gonna go all the way here and everything is broken, and I'm gonna replace a string registers with X registers, and boom.
Actually, now that I think about it, I don't think we need Y registers in the evaluator or the machine because those registers are really just stack locations.
I don't think we agreed on that last time. I think there was a purpose of permanent registers, so that's why we did Y registers.
No, I mean, yes, they have a purpose which is different from the purpose of the temporary registers. So they must be separate, but the point is that they are not represented the same way as the temporary registers. They are represented actually as spots, locations on the stack.
That was not my understanding last time. My understanding was that when you're about to do a call, you're gonna save those, you're gonna manipulate the X registers and the Y registers to keep the context of the previous scope.
Yes, you will, but that's kind of it. Like the way you do that is you move the the registers that you plan to save across the call into the stack, and that's what's called the Y registers. Actually, it's just the stack locations.
But is that just like an abstraction thingy, or is this actually how the books explains it? Because I have no, I don't
I mean,
remember.
it follows logically from how the allocate and deallocate. Yeah, see,
No,
scroll up a little bit to
yeah, I
the
remember that. But
no
if
to the.
that's the no, I remember this. You're talking about these operations.
I'm talking about specifically that diagram at the top of this page. See, that's the stack frame that we implemented in the machine last time, right?
That is correct indeed. Wait, are we gonna have to introduce a stack to the compiler then?
No, we already have a location for the stack in memory.
Oh, in the computer, not in the compiler.
In the computer, yes.
Yeah, but didn't you just say that you're gonna have to change register allocation?
No, I'm talking about how registers, specifically the Y registers, are implemented
No, no,
in
no,
the
no.
machine.
No, yeah, you also said that, but before that, when I was talking about baby steps, you just mentioned that we're gonna have to change how register allocation is done.
Yes, we will, because right now we only allocate the X registers. And we will, in fact, need to allocate Y registers because we need to say, okay, for this term, this variable is actually used in more than one call in the body. So we need to go into a Y register,
Yeah,
you
but
see?
how are we gonna do this? Because you just said that we don't have to add explicitly why, well, at least in the
That's
computer.
that's the computer lemos. The For the compiler, we do need to make the distinction because we're just adding labels to each subterm and saying, okay, this goes to this register, essentially.
Yeah, I think you said both the computer and the compiler before, but well, I'm not gonna be too picky about that. Okay, so we're gonna do Y registers here. That's what we're gonna do. Is that correct?
Yes, because we need to allocate,
That's not
like,
correct.
yeah, we need to allocate which variables need to be saved on the stack.
Yeah. Um, oops. We can also do the same trick that Mageta taught us, like this. Do we have any new something? New compiler. Yeah, we don't want that, I think. Oh, it doesn't make a difference in this case. Cool. Okay, so what's the first thing that we need to do then? Everything is using the X registers now. Let's see if this compiles in, by the way.
Mm,
So Dune exec Karuta. It does. Okay, so what's the next step in your eyes?
let's see. Uh, we have register allocation for
Declarations.
variables, declarations. Yeah, right now we
Only for
kind of
query and
don't.
declarations, by the way.
Yeah, but right now we don't really. If you go into register alloc declaration, I don't think we actually do anything with the body, right?
No, we don't do anything with the body. There's a to do
Yeah,
here.
that's what we need to change.
Okay, so the first thing we're going to change is the register allocation for a declaration. Cool. So, I don't know, this thing. So what's going to be the first thing we're going to do?
Hmm. Hmm. That's a good question. I'm not sure what's the best way to go about it because here's the thing. We need to allocate the registers for each subterm in the body as we were doing, but we also now need to do something slightly different, which is we need to keep track of which variables are used more than once in the body.
Mm, couldn't couldn't we use this for that or something similar? It's the same kind of idea
Variable.
in a sense.
That's for keeping track of which variables are in scope, right?
Yeah, no, I'm not saying we use this literally. We just do something similar. I don't know, maybe
Yeah,
scope variables.
we need something. We need a multiset actually.
A multiset. Can you explain why?
And because here's the thing, a set just tells us, okay, in this scope, these variables are used. But it doesn't tell us how many times each variable is used, right?
It doesn't matter. If it's used more than
It does.
once, we that
It
no,
actually does matter now.
if it no 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 no. Inside the body of a predicate, if it happens more than once, this is already a permanent it needs to use permanent registers, no?
Yes, but how do we tell that if we only have a set?
Well, you just check the set, you do a lookup. Easy.
Okay, so your proposal is to use two sets, essentially.
Why true?
Because we still need to keep track of which variables are used at all, but
Oh,
we
you
also
want to
need to know.
combine them. You want to combine them. Okay. Well, in that case, a multi-set. But is there any advantage of combining them?
Well, it's one less thing to pass around, I guess.
That's I don't know if it's a good argument, that one.
Hmm. Let me take a look at the book actually. It does say something about this. Um, blah, blah, blah. Since the same registers are used for each goal, variables that occur in many different goals in the scope of the sequence. Uh, hmm, hmm. Yeah, he just says that whatever variables are used in more than one goal in the sequence inside of the body needs to be a permanent variable.
Yeah, exactly.
I guess we can use two sets. I don't see any particular win in keeping track of more information than just this is used once and this is used more than once. Like
Yeah,
we don't care about the exact number of times that each variable appears, just that
exactly.
it appears.
Okay,
Yeah, and,
so.
yeah, and don't call them scope. Well, actually I forget the variable set. Um,
It is
what
just a
are
set of
we
tags.
actually?
It is just a set
It's
of
just
tags.
okay.
And a set of tags is basically a string.
Hmm, okay.
Yeah. Okay. Cool. So now, what we're gonna do? We need to, in the register allocation of the declarations, we need actually to extract that one. So we're gonna do scope. variables. I'm gonna have that one. So that's cool.
Mm,
Wait a moment, there's a problem. If you're running like, let's suppose that you're doing a body, right? And as far as I can tell, if there's a call here, you can actually go there, right? Oh no,
that's
but
only
that's
the
evaluation. That's only an
that's
evaluation. We're compiling. Okay, my bad. I was being stupid.
yeah, that's only when we actually get to execute the code. Right now we're just constructing it.
Yeah. Um. Yeah. It's just because at each iteration of declaration, we need to reset this one
Uh,
because each declaration has its own scope.
yes, each declaration has its own scope. So at the beginning of a declaration, uh, yeah, we should actually probably do that outside of this function. But yeah, every time we allocate registers for a declaration, we need to start with an empty set for the scope variables.
Okay, so it's up here. What you said. Uh,
Hmm.
Not that. Here. Um, so we here actually we're gonna pick the compiler. Actually, I can do this in here. I need to pick the compiler, and I think I need to do with scope variables
Equals
uh,
empty.
equal s empty. Yeah, that's what we're gonna do. Okay, so now let's go back here. So we know this is an empty from the start. Okay, then what we do with the first member of the body?
Uh, the first member of the body, in the first member of the body, hmm, we still need to allocate the registers for the head of the rule, right? We're not doing that before this match, I don't think.
Really? I thought we were already doing that.
Hello, Mageta.
Hello, Magetta.
Hello, Maninho.
Oh no,
Hello.
yeah, no, we aren't. Yeah, we're doing it.
Yeah, we aren't doing that. But the book says to treat the head as a fact, right?
Yes, but there's some slight special treatment about the variables in the head because, like, if a variable appears twice in the head and also in the first clause, then we pretend that it only appears once.
Wait, can you repeat what you said? If
Like
there is
the
what?
like a variable that appears in the head um, and also appears in the first clause of the body, we only
Hmm.
count that as one appearance, even though it technically appears twice.
No, but that doesn't matter because when we are compiling the body, we put the scope variables to empty anyway. Because what we're
That
gonna do this, right? Let compiler store, and we're gonna do something about the head in here.
no, 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 no. Inside of the register allocation for the declarations, we just need to say, hmm,
Need to say.
hmm.
I get we are compiling out two. That's what we are doing, okay?
Yeah, I'm looking. Makes sense.
Yeah, this is the version of the language that has bodies. And now we are discussing how the heck we should compile that thing. And we are recording, by the way.
Also, I can't rent.
Yeah, that's why I said. Marinho, continue.
Mm, yeah, like
Okay, let's me first ask the dumb question. Why can't we treat the head as a fact as the book suggests?
Well, the book actually says we can't because the reason we need to use the permanent variables is because when we call a clause of the body that may mutate the temporary registers, right? It may change their
Mm-hmm.
contents. So if a variable appears more than once in the in the body, we need to put it in a permanent uh, variable instead, because otherwise we're going to lose it after the first time that it's used, and we want to avoid that. The reason we treat the head as slightly differently is because the head never actually writes any. It doesn't overwrite any registers.
It doesn't overwrite any registers. I don't understand. How are we generating the code for a simple fact? My understanding is that we are not overriding any registers to do that.
It's basically a sequence of puts, if I recall right.
Oh, this is allocating a fact, right? This is just picking the assuming that there is no body, so this is a fact, and we grab the head and we say it's a functor and just do it like that. That's it.
Yeah.
Yeah. So why can't we do exactly this for the head of the declaration up there actually? Oh wait, that means that we are doing it. The question that you asked before, are we already doing some treatment for the head? The answer is yes. The answer is totally yes. We're doing it in here.
Hmm. Okay. Um.
So I guess we should keep this though. Do you agree?
Yeah, this should actually happen no matter what. Like
Yeah.
it should be
So this
before
will
the
be like
match.
let compiler store this in, and then if that's it, we just say okay, return this back to the caller. Otherwise, we do something about the bodies.
Otherwise, we do something about the bodies. Yes.
Okay, then it comes the question. After we do this, is there any special treatment that we need to do before treating the body parts?
Mm, I don't think so. Hmm.
Although,
Although, if we allocate the registers as we iterate through the body in one pass, um, how do we know that a variable that we see being used in the first clause of the body is used more than once? Like we need to
wait,
know that ahead of time so we can allocate this to a permanent variable
no,
to
but
a y register.
wait, are you talking about a variable that appears on the head, like in this case?
A variable that appears in the head.
Yeah, because my
Well, in this,
understanding is that we don't care about this, and we only start counting from this onwards.
uh, well, here's the thing. The way the book says to treat the head variables is to like for the purpose of deciding if a variable should be permanent or not, is the head variables belong to the first clause. So if we look at this example here, um, the a variable can be temporary because it only appears in the first clause and the head, which is part of the first clause logically.
Yes.
But the b variable actually needs to be permanent because it appears in the head, which is part of the first clause, and it also appears on the second clause, you see?
Ah, okay. What you're saying is that we actually need to remember these variables.
We need to remember the b in this case.
Yeah, no, but damn, this is very annoying then. Because it doesn't matter for the first member of the body, but it does for the remaining ones.
Yeah, because the head doesn't have any puts, right? It only does gets, like when there's a body in the predicate.
But in the book itself, it seems that they don't have special treatments, you know? Yeah, see? You just do get arguments of p0, which is the head. Then you just do a bunch of puts with all the body members.
Yes.
No, but I'm being bamboozled again. This is evaluation. Uh, I keep forgetting that the book doesn't treat compiling at all.
No, this is code emission. Like you need to get the arguments of the variables, like of the head, right? But then you have to do puts for each clause of the body before calling it. But when we actually execute the code, the puts may update the variables, and we don't want to um, we don't want to we don't want to forget the variables that are used more than once. Is the point?
Yeah, I think there's an example here. For example, consider the rule this. So in your example, y is permanent and x is temporary. That's what you want to tell me?
Yeah.
Okay. If the variables y and z were allowed to be accessible only from an argument register, no guarantee could be made that they still would be after performing the unifications required in executing the body of P. Yeah, so Z is permanent and Y is permanent, but X is not, because the head is like part of the first clause.
Yeah.
Damn. How are we gonna do that without incurring to a mess?
And by the way, father is also permanent here because it appears in both clauses as well.
Father is yeah, no, you mean this one, right?
Yeah.
Yeah, that makes sense. Okay, but I don't know what's the strategy we're gonna use to handle this thing. That
Uh,
sucks.
the the easiest way to do it would just be to do it in two passes. First, we go through each clause of the body,
Hmm.
and then we count by using the two scopes, the two variable sets, right? The normal one and the scope one,
Mm-hmm.
to see which variables we have already seen, and um, and if they appear like, and then we just collect them in the two sets, right? And then we will have a set with all the variables and another one with the ones that appear more than once. And then when we go through the actual register allocation, we say, okay, if this variable appears more than once, we allocate it to a permanent register, to a Y register. Otherwise, we allocate it to an X register as we were doing.
Okay, that's a lot of steps. Let's go one by one. So the first thing is to actually grab. Uh, well, if you're gonna do this in a single, so let's say I don't know clauses in here, because we're gonna just do another pass later, and then we can do that recursively again. So the first thing you need to do is to collect the variables you said, right?
Yeah, specifically, we need to uh, figure out which ones appear in more than one clause of the body.
Yes. But how are we gonna do that though? Uh, there's
We
no
just
function. This is no fun. We didn't implement any similar functionality before.
this is this is basically a fold lemmus.
No, yeah, that part I do know. It is a fold indeed. But we're gonna have to inspect probably with something similar to this, right? Because it can be a variable, it can be another functor, it can be many things in there.
That is true.
Yeah, but there's no. We didn't implement any in. Yeah, we're gonna have to implement this. Yeah, okay, this is gonna take a while, but let's go. Uh, okay, let's actually make this function here. So extract variables maybe. What do you say?
Extract variables. Why not count variables? Because that's what we're doing, kinda.
I think we're gonna identify them, no? or we're gonna count them literally in this auxiliary. This is the function for the fold, by the way.
Oh, this is for the fold. This
Yeah.
is not okay. Well, it can be extract variables, I guess. I don't like that name, but I don't have a better one.
Get variables.
That's even worse, Lemos.
Let's go with the longest one then. So what are we gonna receive? Let's actually. I think we're already doing a yeah. We're already doing a fold. So let's go. Let's copy this thing. Um, so where is it? So extract. Yeah, this thing. So we're gonna put a fold in here. Then this function will be extract variables, which I'm gonna say does literally nothing for now. Well, this also needs to receive. I don't know, unit. And then what we're gonna do? What's gonna be the initial thing? It's gonna be a set, right? The scoped variables. Scope variables. And then you pass the clauses, right?
And then you pass the clauses, yes.
So these will return as vars, right?
It should return us. It should return as a new scope set, scoped variable set. Except this one is not gonna be empty, right? We don't
Yes.
expect it to be empty in general, although it may be in some cases.
Yes. Okay, assuming that we have that, what would be the next step? Now we're going to do the second pass, I believe.
Yeah, now we have to actually iterate through the clauses and allocate the registers for each one of them.
Um, yeah, but this register, special register allocation functionality, we don't have that implemented yet, right?
We don't. We need to implement that.
Okay, so let's make another auxiliary function here. So what would that be? Register clause allocation? Alloc?
No,
Is
we can just reuse. I think we can just reuse the register alloc loop, but we will have to modify that to take into account the scope variables that we introduced.
so wait. So you want to modify this function to also receive the scope variables and do something about that.
It already is, because that's part of the compiler.
Okay. So what scope variables, right? So this thing. So how are we going to take that into account here, actually?
Hmm.
Okay, so the first thing that we are doing is actually to grab the terms, which I already forgot what that is. It's a
Actually, I
queue.
think it's not quite here. It's actually deeper in the call stack, because here's the thing: we need to do that when we actually assign a register to the term in the. We have a diction. We have a map for that, right?
No, we have many maps. Which one? Well,
Uh,
in this one we only have one, which is the X registers for now. Yeah, but I think this is happening on the smaller functions, right? We have an alloc variable function, alloc functor
Yeah,
function.
basically everywhere that we were adding a variable to the registers map, now we need to do something slightly different. We need to check if the variable is in the scope variables. That is, if it's used more than once in this particular scope.
Mm-hmm.
If it is, we put it in the y variables, and if it isn't, we put it in the x variables.
Well, I think with variables you mean registers, right?
Well, yes.
Okay. Okay, let's start with the quote leaf functions, which are the specific ones for functors, variables, and so on. I think it's gonna be way easier, actually. So let's start with variables.
Uh,
We receive the compiler in here, so we're gonna actually extract the scope variables, right? Scope variables,
yeah,
and we need to do special treatment in here.
we do.
I have a proposal.
Actually, let me double check something real quick.
My proposal is to make a separate function um, called alloc registers that will return us the new X registers or Y registers depending on, like according to if it should be Y, if it should be X, but we're not gonna know. We're gonna have to handle this in the caller, only in the callee. Does that make sense to you, Marinho?
Uh, Give me a moment. One moment.
So alloc
Register map is a
registers.
bat map of AST.
Ah,
Uh, Register map T of int. I'm actually wondering if we should still have a single registers map instead and just change the value type.
what do you mean by
Um,
changing the value type? Oh, adding like some sort of the temporary or permanent information in the tags themselves?
in the value of the register map, because the key is an AST, because we're allocating a register for a particular node. But the value is an integer because we were only considering one type of register before. Uh,
What's gonna be the
we
benefit of instead of being an integer being a pair?
we only have one map for the register allocation to worry about.
Um, well,
In particular for the user of the register allocation, which is the code generation, right?
well, it's there's still time. Do you want to change that then?
That's probably for the best, and there's a second problem actually. Right now, uh, we keep count of how many registers we have allocated, right?
Yes.
We need to keep two counts now.
Yeah, but that sucks.
C'est la vie.
Wait, but that's gonna be happening even if you go with a single registers, right?
It will, yes.
Yeah, that sucks ass, dude. Okay.
Yeah, because like y0 and x0 are different, completely different registers, right? And
Yeah,
if I need seven temporaries and I only need one permanent, like
that
we
sucks.
can't allocate y6 or 8 or whatever. It needs to be y0.
Okay, so let's go by parts. Do you want to have a single registers or two registers?
Um, I would prefer a single register map, um,
Okay.
just to keep all the information about registers in one place.
Okay, so let's replace the string again and let's call x registers. Registers. Let's call those only registers again. Boom. Nothing is broken. It's fine. It's not fine. What do you mean? Oh, I did the replacement wrong. Okay, so now it should be fine. Yeah. This is the code that was already broken that we are touching it. So, next question. Does the permanent versus temporary information, does that matter only for code generation and compilation, or that matters for someone else?
Uh,
I think it should not matter for someone else.
no, it doesn't. It only matters, like, we're going to use this information in the compiler to construct the code that will be executed in a certain way.
Okay, so let's create a type for this.
But then after the compiler is done, we will end up with just the code, right? We
Yeah,
don't.
we're just gonna execute the computer memory, basically.
Yeah.
I'm lacking creativity for names. So which name should we put for temporary versus permanent? And I don't remember. Is that how you do that? Yeah, that's how you do that. Cool. Um, oh wait, we can just do what you did before, right? This thing.
Yeah,
Yeah. What's the name of this thing though?
it's a register.
Register. Okay, so this will now be gone, and this also will
And
be
we need to
gone.
yeah, and we need to change the int to be register.
Register. Okay,
And
everything
that
is now broken, right?
it should be, yes.
Yeah, but then we're gonna use that in the compiler system refactoring to know which places we actually need to put the thing, right? The
Yeah.
changes, the check. But I want to before that I want to make a special function, a lock register that will pick the bank of registers and return you the new one, and do all the handling if it should be permanent or not in here.
That's probably a good idea, yes.
So we're gonna have a registers, which is basically this type.
We actually probably should take the entire compiler, to be honest.
I was just thinking registers and scope variables. Do you think we need the entire compiler?
We do, because once we allocate a register, we need to bump the correct counter to say, okay,
Oh, okay.
register.
Let me do this first though, because you just reminded me that I also need to change p register to something else. P register. What are we gonna call this? PX register?
Yeah, maybe, and py register. Those are terrible names, by the way, but I don't have a better idea, so.
Sure. And then we're gonna do the same thing with py register.
We have a crowd today.
Yeah, a lot of people watching us put tags on a tape.
People are in excitement, waiting for the provisioning of the new Crazy Ink initiative.
I
That reminds me, I'm not sure if what I'm going to put there. I haven't posted anything on the
Oh yeah, let me
thing.
see if we have new responses.
um
Oh wow, we have a lot of responses. We have 10. No, actually 9 with mine included.
yeah, I also didn't respond yet.
We're
I
gonna
also
have
don't know.
enough people to do crazy stuff.
Yeah. So you said the entire compiler, right, Maria?
Yes, because we're going
And
to need
variables and scope variables.
yeah, we're going to need to look at the variables, the scope variables. We're going to need to bother with the two counters, right?
Oh god. Okay. PX. Register. PY. Register. And ignore everything else. And we're gonna also receive the node, right? That we're trying to do. So this is like an LM in which we have an AST dot T then. Is that correct?
Uh, yeah, that seems reasonable.
And what we're gonna return? We're gonna return T,
We should return a new compiler, no?
which is T, right?
Right, because this is the compiler module and T is the type of the compiler, yes.
Yeah, but there's something wrong going on. Oh, there's extra parentheses, I see. Yeah. So this is the alloc register, right? So the first thing that we do is to match the LM. Is that what we're gonna do?
Match DLM.
Yeah,
I
because the
don't
body
think.
is a bunch of LMs, right? Am I wrong? The body of a declaration is a bunch of LMs. Where is that happening, by the way?
Uh,
Uh,
no lemons. We just need to check. Um,
Wait, I forgot. Where are we doing the... Oh, AST here. Okay, sorry. So if there's a declaration, there's a body, and the body is a... Oh, it's a list of funcs, actually. And a func has a tag and elements and so on. Okay, you were saying?
uh, one moment.
have no idea of my relief to need a CLI, and then I go see what language it is, and it's not Python, it's Golang. It's a huge relief because I know it will just work.
Let's
It
see.
will just
Uh,
work.
Wait a second. Cardinal. Oh, I think I see what's going on. Um,
You see what's going on?
Apparently we're not actually using the p register in the compiler.
Using the p register in the compiler. Wait, are you sure about
Oh, we
that?
use it for generating code.
Yeah, we definitely are using the p register.
Oh, the p register is not actually used for counting the registers that have already been allocated. It's actually counting. It's used by the code generation actually to keep track of how many instructions are already in the tape.
No, but then I don't recall. Did we do that following the book or we made a mistake?
No, we do need to do it this way because we need to know. Okay, this particular place in memory already has an instruction, so the next instruction goes after that, right?
Yeah.
And the way that we are actually keeping track of the how many registers were allocated is we're just counting how many entries are in the map.
Hmm. Oh, so that's what Cardinal is doing.
Yeah.
So are we gonna change that? What's your plan? We're gonna
Hmm.
have to change that if we want to use a single registers map. We need to change that. If we are using the other way around, which is to do two thingies, then we could maintain the same strategy.
We could. Uh,
Is there a
Trans
cardinal
register.
function that you can pass like a predicate,
I don't think so
like a
because
lambda?
no, because implementation wise, cardinal is just reading a constant from a particular offset of the head of the map.
Okay, I see the
Hmm.
I see the situation, the dilemma here. What do you suggest?
Hmm.
You're using a bet map, bet map.
What do I suggest? That's a good question. Hmm. Hmm. This is kind of tough.
Yeah. Yeah. I'm really surprised there's no cardinal with a lambda.
Well, you wouldn't be if you knew how these things are implemented.
No, but there are functions that are almost what I want, which is like, oh, for all and exists. It's basically a very similar function but returning an integer here, and this being a generic lambda. So I'm a little surprised, not gonna lie. Yeah, there's no way. We would have to do that manually, and that sucks. That kind of
The
sucks.
reason I'm not surprised, Lemon, is because
Man, it's exactly this type of function. Ah,
yeah, I'm assuming that this is implemented I'm not sure if it's a hash array mapped tree. Probably not, right? Because this takes a sorted key, so it's probably some kind of binary tree. Um, and it's not very difficult. Like if you need to keep a binary tree balanced, um, you usually need to keep track of some extra data besides just the key and the value. And it's convenient to use the size actually of the tree because that gives you length in constant time for free
Yeah, no,
basically.
that makes perfect sense for length. I'm not complaining about that part. It is just that they have functions that check for the entirety of the thing, but instead of you being able to like have a more generic thing, they've locked into like booleans. Your favorite, money.
I mean, this is some set theoretic stuff, right? It's for all and exists, but yeah, I agree. Booleans is like, well, it's
Okay,
Booleans.
but how
What
are
can
we
you
gonna
do?
do this though? Because if if we do this way that we're currently doing, which is to have a single registers map, we're gonna have to introduce two new counters and backtrack the P register. Well, we're gonna have to backtrack the PX register to P register anyway, but um, if we go with the two register maps for the X and the Y, then we can use cardinal to know the next thingy.
We can, and that's a plus, but that will complicate the code gen later.
Okay, so you suggest keeping it as one and having two separate counters.
Mm, let me actually go over the code generation because it's been, well, it's been a week, but well, no, it's been more than a week. Last week we did something else.
No, we did
Uh,
this. Last Friday we also did this.
no, I'm talking about the actual code gen.
Oh, yeah.
Emit query argument, add instruction, emit top level stuff, compiler variables,
Um,
get index register, find value registers.
I think we're gonna go with your idea of keeping two things and just like accepting that we're gonna have to do two counters. I think that's the best way. I'm gonna
Okay,
backtrack the PX register to P register as before, and now we're gonna have to have uh, X register and Y register. So X, and we're gonna have to have them in here. But here's the thing: when we do an allocation, oh, but we're gonna swap all the allocations to use this function, so it's not a problem. So this function will be the one changing these registers actually. Cool. These counters, I mean to say. Okay, let's
yeah.
go back to here. So now we're gonna have X register, uh, Y register. Okay, this is the function that uses the most amount of stuff of the compiler.
We
Holy
don't need the
freak.
p register here actually. The p
Yeah.
register is just for, yeah.
Okay, so I checked in the st.ml, and the body of a declaration has a bunch of functs, each one with these fields. Does that make sense to you?
Yes.
So I'm just destructuring them in here. So I think the first thing you need to do is a lookup, no?
Is a lookup.
Using this
Uh,
nameF.
Actually, no, it isn't.
Okay.
Because here's the thing, this function is what we're going to use to say, okay, I need to allocate a register for this particular element, right? For this term.
No, but if we do in terms of terms, we need to change this to just
I think we're using
length
AST nodes, right?
t.
If I'm not
Yes,
mistaken.
we are doing EST nodes, and then they can be all of these. So they can be variable functor and so on and so forth. They can be these things.
Hmm.
So we have a var. We're gonna do something about that. You have a
The
func.
problem is that we do it differently for each type. Like if you go down to the register alloc functions for declaration and for functor and variable and so on.
Yeah, this is the variable, for instance.
Yeah, they are all different.
Yeah, but we're not gonna do this anymore. That's what I'm saying. We're gonna swap every single place that is using cardinal of registers and so on and so forth. This is gonna be a call to the function that we are implementing right now.
Hmm. Well, in that case, it actually is not a responsibility of the function to determine which map to put this into.
It should be. We're gonna pass the compiler to it. So
All right, there. We still have a single map, right, for all the registers.
yes, single map for all registers.
Uh,
So my idea is like we're just gonna centralize all the register allocations in a single place, and then we're just gonna call in the smaller functions this function. That's my proposal.
uh, well,
And I do think somebody used ChatGPT on the form. Like,
what?
man, this response makes no sense, dude. What the heck? Like, look at the response.
Yeah, wait.
It's a bunch
Be
of
careful.
bullet points. No, it's fine. It's a bunch of bullet points, right? So it's saying UI front-end team renders the data received from the API gateway on the web page. Provider user-friendly, blah blah blah.
Someone used
Apache
ChatGPT.
Kafka or RabbitMQ are excellent choices for robust, high-throughput messaging. We can use Nix to package the chosen message broker as part of the environment.
Yeah,
Deployment. Flakes. Each microservice will be packaged as a Nix
Man,
flake.
I
This
can
ensures reproducible builds.
I can
Man,
100% imagine Benet asking GPT saying some keywords like nix and stuff like that, and he just copy paste.
it wasn't Benin because Benin has another entry. It's another dude
Oh, it's
on the
not
server.
anonymous actually.
Yeah, it's not. It's
Okay,
another
so
guy.
not
Yeah, I'll
don't
not saying who, but yeah.
yeah no. But after the recording, I really want to know.
Yes. Anyway, I'll give one last warning, and then we can go over it on the end, and then just make the uh, a date for like in the very future when people want to do it.
Yeah. Okay, we can go over that. Maninho, what do you think about my proposal?
uh, okay, here's the problem. We are going to essentially need to do an add onto the registers, right?
Yes.
We're going to need to
Mm-hmm.
yeah, we're not going to match DLM, by the way. We're just going to add it
No,
to
my proposal
the.
does matching on the LM, so I'm waiting to you to finish.
Yeah, because here's what we need to do. We need to add the element as the key in the map with a
Okay.
register associated with it. We are going to take the register and the element as arguments, which we're already doing. But then we need to um, actually we just need to say
Oh, actually, you're
yeah.
right. The the we don't need to match on the LM because we should match it because there are unreachable cases. But in theory, you're right. We can just pick the LM and put it as the key and call it a day.
Uh, I guess actually what this function would do is to determine. Yeah, okay. Here's what we're gonna do. This function is just going to take the compiler and the element. We need to add the element to the registers map.
Wait a moment. We're gonna start by adding
Um,
the lm, and that add doesn't make sense because I need to do this open. So there. Then how are we gonna know which X register, Y register to use? Um, yeah, how are we gonna do that? And if it's permanent or not, we also need to define that.
mm,
So like X register temporary or something. Temporary, and I did bullshit because this is this, and this is not a tuple. This thing, something like that, right?
something like that.
But I need to define if it's a permanent or not before doing this. Agree on that?
I agree. And hmm,
So the
scope
first thing you need to
variables
do
is
is an
just a
if.
set of names. Yeah, we need to check if the thing. Oh boy,
Yeah, I think you're seeing. I think you're having the vision.
Division.
Yeah.
it's one vision.
Oh man, I have stories about division.
No, it's not the vision. It's one vision. It's different.
No, I said the vision in my statement. The vision.
You did, and I replied one vision. Okay, here's the problem. We need to check um, if the thing.
If
We
the
need to
thing.
check if the thing that we're putting, if the register that we're allocating, if the term that it's well, the variable that will hold the value of the term is it appears in the scope variables, right? Because that's where we're going to put
Yeah,
the
so
variables that
here's
appear.
where we need to do the pattern matching, as I was talking to you before. Because the name, like the variable name that is inside an LM, because this it can be multiple things, we can't just extract the name out of this thing to do the lookup. We need to pattern match to see if it's a var or a func, and then extract the names out of those.
We need to see if it's a variable first. If it's a variable, we check if it's in the scope variables.
Okay, so match lm with if it's a variable.
Yeah, we get the name, check if it's in the scope variables.
Wait a moment. I forgot how to do the. Oh, it's like this. Thank you. Thank you, previous us. This is how you do that. Okay. Then you check what?
We check if the name is in the scope variables. I'm pretty sure we're using the same type for the name and for the
Yes,
element.
yes, yes.
Yeah.
Name v variables. Then
Uh, if it's in the scope variables, then we need to allocate it to a new permanent register.
so you're saying that we're gonna do. Wait. We're
We're
gonna
going
do.
to,
Wait. I'm trying to keep up. We're gonna allocate permanent. You said right?
yeah, look, this match is going to return a register, okay?
This match returns
A
a
register, yes.
register.
It returns a register.
Ah, I see. So let that. Then you want me to make it this and this. Yeah.
Yeah,
Go on.
if it's a none, that means this variable is only used once. So we do a temporary. Um,
Temporary y like that.
yeah,
Here's the problem though. We need to know which one to bump up, right?
the register tells us, but it's kind of annoying, right?
It is kind of annoying. Well, we can do the following.
That works. Yeah, in the temporary case, we bump the Y register in the X register. I mean,
Yeah,
yeah,
I
the
did
X
the
and Y are
opposite.
flipped,
I
by the
did
way.
I did
Yeah.
the opposite. Okay, in this case we do this thing, and in this case we do this thing. Cool.
Yeah, and if it's not a variable, then it's always a temporary.
Oh, okay. If it's not, the I think my LSP is getting confused. Okay. If it's not,
It's
well,
always temporary.
we should not do a catch-all, but uh, for now I'm gonna do it like that, right? Then here we just grab this and put register, right?
Yes, and then we return a new compiler.
Wait, I have a question. This is not using the scoped variables.
It is.
It isn't.
Well, it should be on line 57.
Okay, but didn't you say before that we were supposed to be using variables as well?
Uh, hmm. What are we actually using the variables for? I
We are
forget.
using it here to the add instruction. We are using to know that if a variable inside a fact is being used more than once because it changes the compilation process in here. See here? In the emit argument function, we check if the variable is already within the variables that we already have seen, and if it is, we do.
Oh, but that's code generation. It's not register allocation. That's a separate step, Lemos.
Yeah, so this is not going to be here then.
It won't.
Yeah. Okay, then we do this. Then you said we do compiler
Compiler.
with registers.
Registers, X register, Y register.
Yeah,
Uh,
X.
I don't know why, but whenever I hear computer, I remember of sorry, my tongue is a little numb today, so I'm not talking perfectly. Um, but I remember uh, the commercial of the Apple Macintosh Millennium Edition.
I don't know the Millennium Edition, but I do know what you're talking about.
Sorry, the 25th anniversary I mistook with the Windows ME.
Well, I also don't remember, but continue.
Well, anyway, I just remember that commercial where the guy says, "It's more than a computer. It's a whole experience." And it's just a thing floating there. It's just beautiful.
Yeah. Okay.
Anyway, that was random, but
Yeah, no, but that was good memories. Is that it, Marinho?
Yeah, and now every place that adds a register, like using the add function, we will instead call a lock register.
This broke for some reason. These expressions has type register, but an expression was expected of type int. Wait, what?
Oh, right, because we had only one type of register before, and now we have two. We changed the value type of the register's map. It's not an integer anymore.
Yeah, but what is? Uh, I'm really confused. What is this again? Variable. Oh, it is this. Wait, but this has nothing to do with that, dude. This is creating instructions, right? This is creating instructions. What this has to do with anything? I am confused.
perplexed. Say that.
Yeah, perplexed is also a good way to say that. Do you understand what the heck is going on? It's because now this thing, this find returns a register, not a number.
Yeah, we need
Okay,
to actually, yeah.
okay. Um, okay, I didn't foresee that happening, but good. Let's change
Uh,
the places that we do the
I
addition
hate the
first, though.
comic.
All right.
So instead of calling this thing, we're gonna call. Oh, actually, you said that you're gonna return the entire compiler, right? So, um, how to do that actually. So just this, I guess. This. No, no, no. We need
Uh,
to actually have the entire compiler here, and then we're gonna do a lock register and the
ANC
arguments of,
variable var
and then yeah, this thing. Oops, this thing,
and the
and
previous compiler as the first argument or the second. I don't.
it's the first. Yeah, it's the first, and then
Why,
we do
whenever
this.
I am in a Nekoma session, I feel like eating a burger. That's not normal, is it?
Yeah, but burgers are good. I like them.
The answer is
Uh,
Pavlov.
Man, it's not even like a gourmet burger. It's just like a McDonald's burger. I don't know why. It's
I
just
don't
not
know why, but it
Pavlov.
is what it
it's
is.
bigger than me, man. What the
Yeah, the answer is Pavlov.
heck?
Uh,
Thank you, Marina.
but that was great. Um,
I
okay,
swear I heard paton coming out of of your mouth.
No, it's Pavlov, as
Yeah,
in,
it's Pavlov dog. Yeah, I literally heard paton.
nope.
no pattern today. Um, that's it. There are only two cases, Marin. Believe it or not.
Huh,
Actually, that
okay.
makes sense because we only have register a lock for. Oh no, that you can need to keep that. We only have functors and variables that we really care about. Everything else are just layers on top of those.
That's amazing.
Cool. Okay, so now we need to fix these. We actually need to fix these. What's your suggestion?
Okay, here's the problem. The register type for the compiler is not the same as the register type for the computer.
Yeah.
That means we need to pattern match on the. Oh, actually, we can probably make a helper for that.
Yeah,
That
I'm gonna definitely make, and I'm gonna use extract again, even though you don't like it. Extract. I'm gonna do
this is
what?
because of the book club, isn't it?
No, it's not. But now that you said, now that you remind me, I'm gonna say it is.
Okay.
So this is register type. It's so nice that I can do this. Same name, but different name, different spaces in the thing. And this will definitely return an integer. And
No,
actually,
it should actually return a register for the machine. In fact,
should return what?
because previously we always emitted codes for temporary registers because we didn't have permanent registers, right?
Yeah.
Now we need to say, okay, if the register that we allocated was for a temporary, then we need to actually yeah, we need to actually emit an instruction that uses the X register, and if it's a permanent, then we need to emit an instruction for the Y register. You see?
Ah, I think I'm starting to understand. Wait, does that change anything in terms of the instruction that we are creating? Because all of these failures are because of instruction generation.
Uh, Kinda, because we always, as I said, we always generated this X register. Now we need to be able to generate both X and Y register instructions. But the temporary and permanent registers that we have in the compiler just map directly to the X and Y
Ah, okay,
registers.
I see what you're talking about.
Of
So
course, my environment broke because of Python.
what you're saying is basically to do this type of thing, then, or something.
Yeah, and the permanent will be cell Y instead of
Uh,
it's not an instruction, it's a register. Although I don't remember if that's
I
the name
don't,
actually.
I don't think that's it's register. Register. And in here we're gonna do cell y value, right?
Yeah.
Okay. Uh, yeah, but then we need to change because now I know what we're supposed to be doing. What should be the name of this function? I'm gonna call a cell register and call it. That's it.
Okay.
Okay, so then I need to pass. Wait a moment.
Oh, that's already a register
Yeah, but there's a
instead of an
problem.
index.
Yeah, but there's a problem. Do you see that we are receiving constructors here
Yes.
and they're expecting integers?
Well, they should expect registers instead.
Okay, so you're saying to swap this with this. But that's not going to work because there's no instruction that does that, actually. Yeah, there's no instruction that does that, dude.
Mm,
Wait, but how are we doing this? We are calling emit argument and we are calling unify variable. And unify variable, maybe we need to upgrade these things to instead of using integers, use registers.
no, 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 no. The string and integer are for the functor.
No,
The
no, no, not
register is.
not these ones. Sorry, but what's the one that I was looking at? Unify variable. Unify
But that
variable.
already takes a register.
Ah, I see, I see, I see. So what you're saying is you do this type of X and you just
Yeah,
pass
that's
V
just
here.
gonna be. Yeah. And
Uh-huh.
again, we're doing this because, well, constructors are not functions for some reason.
There's probably a good reason though. I like to imagine that there is a good reason.
Even in F sharp, they are.
What is it complaining about then? Now.
We need to. That's index of register is no longer an integer. It's actually a
Yeah,
compiler register. We
yeah,
need
but
to.
now I changed these things. They should be receiving registers, which
They
they
are,
are.
but we're not passing registers to them. We're passing something that's. We're calling an index of register. Previously it was an integer. Now it's a compiler register. We need to call the cell register around the find the lane registers, basically.
Wait, which line you're saying that?
Line 90, actually.
90. Oh, you mean to put the cell register? Uh,
Yeah, you put parentheses around the find the lane registers. Or that works.
uh-huh. And then the same thing happens in here. It's such a like I can't believe that we need to do this type of shit because the constructor is not a function. Really, dude.
What are you guys doing? Let me see.
Like, look at this monstrosity. We need to pass. We want to pass these things as arguments to this function. But this is not a function, so we had to
Oh,
make a
yes.
lambda.
Yeah, you have to
Like
wrap it.
this is atrocious. Like this is
Yes,
why.
this is garbage. Yes.
Like what the heck is going on? Uh, tá,
This is
cell.
not in fact why this is eta expansion.
Yeah. And instead of calling this index, this is just register, and this constructor here can go away. Cool.
Thank you, Golang, for compiling fast.
Why are you using Golang? Can you answer that?
CLI for database tool.
Oh. Uh,
Did I buy a Postgres mug for the lunch?
I thought you would ask, should I buy a burger? I was about to say yes.
You're about to say yes. You didn't.
I was really about to say yes. So register that. Wow, we have a notion of a temporary register and a permanent register now. It's crazy.
Wow, man, we have like a lot of people today.
Yeah.
It's a jolly jamboree.
Oh,
Thank
it's
you.
things are
Mario
happening in the
Party
chat.
Jamboree just released, by the way.
Okay. Marinho, that's it. So now we can go back to the register alloc declaration, right?
Register a lock declaration.
And we are doing the head allocation first. What we did basically introduces the notion of permanent registers and temporary registers for everyone.
Yeah.
That's what we did. Now we can go back to where we started, which is we just allocate the head, and then what we do with the body now.
Actually, I have one more concern, and I just thought about it.
Yeah,
Uh, Whenever we reset the 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 scope variable set back to empty, right? Whenever we do that,
here.
we should also reset the we should also reset the counters for the temporary and permanent registers.
That is true. Okay, I'm actually gonna make a function for that because holy fuck. Um, uh, compiler, and then compiler with scope variables.
Okay, I hate Golang.
That was fast.
Well, just like the language, right? Go
uh,
fast, eat fast,
that
hate fast.
Gotta go fast.
Man,
and that.
command.
Wait, you can do an end with a rec there?
You need to put a rec on the reset scope, I think,
Really? I don't think
and
that's
then you
a.
get rid of the rec after the end.
Oh man, why do you need
Okay, I didn't know that one.
NVM for this?
Then we're gonna reset the compiler. Reset scope of the compiler. Is that it, Marinho?
I think so, yes.
Nice. Okay, now we can go back to what we were doing before. So this thing. So because we are doing the register allocation by like externally, we don't need this anymore, right?
Yeah, no, I don't think so. Actually, yeah, no, we don't. And then
We are
to
doing the
actually,
allocation of the head, and then what we need to do now is the clauses, right?
uh, okay, here's the problem. We actually need to collect the scope variables before allocating the registers for the head.
Why?
Because otherwise, if there's a variable in the head that appears more than once in the body, it's going to be a temporary.
You're actually right. Uh, Wait, but we don't like you said that we need to do this before compiling the head. I don't think so. We have the head externally. Can't we just compile and reuse the head here? Does it make a difference that we are doing the registry allocation for the head?
It does, because it's going to allocate everything in the head to temporary registers because the scope variables is empty at this point.
You're right, actually. Wow, this shit is complicated, dude. Okay.
Did you expect it not to be?
Like, I'm not very well versed with logic programming, to be honest. I'm
This is not even logic programming, it's just register allocation in a compiler.
no, it isn't because
This needs to be distributed.
I
No.
never like when we did our stuff for the for our, in our language. This type we didn't have this type of notions of like temporary and permanent at all. So all of my language development was based on that project, and we didn't have to do that ever. So, but
Were
anyway,
you actually emitting code to like?
no, it was just an interpreted language.
Yeah, for an interpreted language, this honestly doesn't matter.
Yeah, but okay, I'm learning though. Okay, so we need to extract the variables from the head and the bodies, and you like combine them.
Yes, we do. We need to extract the variables. In particular, we need to.
Okay, so there will be
Hmm.
head variables, which is going to be extract variables. And we're going to have to do something about the head. Then we're going to have a body. Actually, we can do in a single shot. I don't know. There's no need to actually do them separately. We can even call these extracted variables. Yeah. So, and we already have the head and the body here. So, what would this? Let's start extracting the variables, Manny. Then.
Hmm.
Do you guys trust a database called ArangoDB, where the logo is a avocado?
I need more
What's that
information
about?
to
Think
do
with your
this.
hearts, please.
If your heart.
Don't think I would.
I think I would give it a shot. Yeah. Okay, so let's extract the variables. Let's extract the variables. So, what is again? What is a head? And that's not the correct place. The
What the
head.
heck does it mean to have a multi-model database?
Yes, I don't know what they mean, man. What the heck? They're just making things up. That's what I believe.
Okay, so
Man, that's gonna be very complicated, no? Because a head is a func, and a func can have elements inside and shit.
we need to do basically tree walking. We need to go down to all the leaves. Like the head is the root node. We have to go down to all the leaves, find which leaves are variables, put those in the.
Yeah, it's basically tree walking, right? But we need to do tree walking like in the head first, then first clause, second clause, and so on and so forth. You see?
Hmm. Actually, I think we may need. Okay, this is actually where a multiset would be convenient.
All of this to go back to that.
Because you see, if we have a multiset of variables, we can just throw them in there and like
It's magic.
we don't have to worry about how exactly they got there. We just have to worry about how many times they got there. I mean, the head and the first clause being considered the same is kind of annoying
Annoyance.
corner case, but other than that,
No, but I
we
still
can
don't
leave.
understand why we need a multiset to do that. Like,
Hmm,
isn't it just a matter of like let extracted head variables, and then we're gonna make a generic extract function, extract variables, that we're gonna pass the func out of the head. We're gonna have to pattern match on this thing and do stuff. Then we're gonna do the same, and this function will be recursive. We'll check the variables, the leaves, and so on and so forth. These will return a set of all of the variables that appeared in the head, like recursively. Then we grab the body. The body is composed out of a bunch of stuff, right? It's a list of funcs. So it's a list of lists in a sense. It's a list of lists. And then we just fold the body. And that's going to be extracted body variables.
the problem is that this particular set is not the set that we need to return.
Oh no, baby steps though. We are doing some stuff. Variables. Well, there will be a function. There will be a function, and then we're gonna put a body, well, body func in here, and then we go from there. What do you think?
I guess.
I guess.
Didn't sound convincing.
Oh yeah. Like, to me, that's what we need to do though. And then we can do. Actually, this should not be a list. This should be a set. Wait. What this should be actually? What should be the result of extract variables?
It should actually, if we don't want to use a multiset for whatever reason, it actually needs to be a list of sets.
A list of sets.
Yes, because we need to grab the sets of the variables for each clause of the body, and we need to do the special treatment for the first one, but okay. And then we need to see which variables appear in more than one set.
It's a
Okay, do we have
sound.
multi-sets in batteries?
Maybe. I don't know actually.
If does batteries accept a, well, it has to accept a base type, right? So you can just build compose it with another.
Yeah, no,
Just build a
but if they
module
no,
with
yeah, but
another
if they have
module.
a separate one, Magetta, probably they have convenient functions already implemented.
Oh, I see. So you're after the
They
functions.
have a multi-map, which I don't know if it works for us, but they also what the heck is a Marshall though?
Marshall is
Yeah,
to convert, right?
it's a what?
It's like to convert a structure to another, right?
Yeah,
Uh,
marshalling basically means you have one
oh.
encoding for some data and you want to transform it into a separate encoding to use in a different context.
Ah, okay, makes sense. Yeah, I am looking for the functions. See you, potato.
See you, potato.
I
Very
am
good,
looking for
man.
the functions, Magetta. I am that lazy. Thank you very much.
Well,
Let's
you are a
see.
Haskaller. Makes sense. Isn't it just a matter of composing two of them, if it's the same thing?
uh, well, yes, but
But you don't have compose as well.
no. I think you can do that actually. You can actually put bet. What's it? Where? Yeah, s dot. Yeah, st something. Like you can do that,
Mhm.
but I think it's gonna suck. I have a
I
Well,
mean,
feeling.
the types
worst,
will mismatch.
worst case scenario, we can actually use a map and do the management of the number of the map,
Oh,
like
the
the
value
number
of
of
the map
bits.
is a frequency?
Yeah, that's what a multiset is when it's implemented in a programming language. It's a map of frequencies.
I think that's gonna work better than trying to do because like what Magetta said is totally doable. Like multi set. Then we would do what? AST something ST, and then we would have to make well convenient functions to handle the nesting of shit, but
It needs to
doable.
be it needs to be not a set actually. It needs to be a map from AST to integer.
Mm, no, yeah, no. I was just talking about the previous idea. Um, question: should that live in the compiler?
I don't think so because we're only going to use it to construct the the scope set.
Okay, what should be the name of such map? Frequency? Yeah, I think I
Uh,
should not do that. That's gonna be confusing as fuck. Let's not do that. Uh, this.
we should
Wait.
probably not use ASTs actually because we're interested in the in the
In
in
the
variables
names.
only, right?
Yeah,
And
so
the
it's
variable only has is identified by its name. So
yeah, so it's a bat map. Wait, don't they have this S map or something? S. No, they don't actually. Okay, so bat map make string. That's not how you do that. Oh, this expects a module. I keep forgetting. Magetta,
yeah,
what's the module of a string?
Uh,
string
the
is a
body of a
type
string
though.
is capital S
Capital S?
string.
Okay.
Yeah.
And then here we're gonna do variable map. And that didn't. Oh, of course. Okay. Let's actually also put var
Very funny
there.
that whenever we end up doing OCaml, it always end up in a miserable experience.
Well, but it isn't actually. It's been a while that it's great. At least for me. What do you think, Marinho?
I mean, as long as you use batteries, it's pretty
Yeah, I
okay
was about to
actually.
say, if you just use
As long as
batteries,
you
you're
use
good.
another library that's like extending the
No,
what the
it's not.
language should give you,
Yeah, but it's only one library. We're not asking for like 50 libraries. It's just this one.
you just want like sort, right? Like simple stuff.
Yeah, true.
And yes,
Yeah.
it does have sort, but what about the rest?
Yeah,
That's
no,
my
but for
question.
now, I'm very happy. Like, I'm really liking OCaml in this experience so far. The only nitpick thing that I don't know how to fix, but you said you know, Mageta, is to fix this type of shit here.
Let me see. What? Fix what exactly?
This thing.
What do you mean? You're just unpacking stuff.
Yeah, but we like there are lines that we're doing like three, four times. Yeah, you see? Let compiler store, compiler store, compiler store. This is basically state monad, but doing it by hand.
Ah, okay. You want to do a monad. Okay, a state monad.
Yeah,
We
then we don't have
could do that
to
with
care
like
about this thing.
the overriding a bind, like the syntax with the let, right? I think it would improve the readability a little bit.
I mean, there's a trick we can do, but I'm not sure how much you're going to like it.
Go for it.
Um, right now, we have the convention that the compiler and the store, they are the first argument for most of these functions, right?
Oh no, I think I know what's coming. Go on.
Here it comes.
If we make it the last argument,
Yeah. Yeah. I totally see what's going on.
It's always when these suggestions start.
Yeah,
yeah,
so
if we make it the last argument, then we can just partially apply all the arguments except the compiler and the store,
yeah,
and that becomes a
do this
function
type of
from
shit, right?
compiler store to compiler store, and then we can just do normal composition.
Yeah. Yeah, that's definitely something that we could explore. The problem is that there are instructions in the middle. So for instance, this one. You need to do this first, and then you need to do these two things, and then you need to do those. So sometimes shit's like this is gonna happen. You're gonna have to break the composition, and then well. But I agree with you that we could optimize this later on. Compiler
I
monad
mean, we
coming.
can. I mean, we can always do continuation passing style, but that's suffering.
Actually having to do that in Emacs Lisp to do things to simulate as if things are not just monothreaded.
Yeah.
Crazy, crazy.
I'm doing event sourcing that, by the way.
Wait, we already started your part of the process?
I was on a meeting that lasted 3 hours, and I got to do a better interface than the library I use at work already.
Okay, that's
I'll show you
awesome.
guys later.
That's awesome. Okay, so wait, before I started saying that, oh, okay, here. So I need to implement this function, right, Marinho? Extract variables. Extract variables.
Yeah, it's basically going to be a tree walk. We need to
Oh, we were
parameter the.
defining this map. Sorry. I forgot where we were. We were talking about doing a var frequency map. That's what we were doing. Bye, Vinicius.
Bye, Vinicius.
Bye bye.
Yeah, so let's do that then. So this file is getting okay, 200. It's still okay.
Your
Uh,
tolerance for file length is kind of low, Lemos.
no, it's just because this file is so. This is the biggest file already. I was just confirming that we are not like 500 lines already.
Okay.
Because
Imagine
like
him
my
reading
threshold is
Nathan.
between 4 and 500, I would say.
Imagine Lemos reviewing Nathan's code.
Yeah, that would. I think I know what you're talking about. That would not be good. Yeah, have
Uh,
a good OCaml.
did you know about the lore, by the way, Marin?
Which lore?
No.
So Nathan is an OCamler, right?
Yeah.
Or should I call Tuareg? I don't even know. Uh, but he basically the tooling was so bad that he used to not bootstrap projects. He would just bootstrap it once,
Yeah, that. Yeah,
and
that.
then he would just reuse the same project for doing multiple things just by reusing the same file with modules and entry points differently, like
Yeah.
located.
He got
That
traumatized. He got
sounds
traumatized. He got completely traumatized.
that sounds terrible.
Yes, it is
Yeah, but it's
horrible.
true.
It is true.
It's totally true. He did that, and he didn't even care how shocking that was.
Yes, it was just. I mean, I live like that. Sorry, it's literally the thing, the meme you sent. I live, I thrive in the trash. Literally that.
I just noticed on this level we only need the head. There. Okay. Yeah, and then on this level is the one that I should pattern match. Cool. Okay, so let's go. So we're gonna have this thing. We're gonna have
Wait, are you
that.
doing extract variables directly for namef element arity? That's just a head, right?
That's all of them actually, because a body is a list of them, a list of what the head is. So I'm making the function that we're gonna use in the folding and calling the head.
Oh man! Oh, thank you,
The,
Lemus. You just reminded me of something absolutely cursed that I have to show later.
Okay.
oh, I'm kind of
Postgres
scared.
was going to be a common list project. They did
Oh,
it. They didn't continue with that, and that has consequences.
wait. It was supposed to be a common list project and it isn't. And what are the consequences of that?
They have let's say they have a C structure because they were making their own Lisp on top of that, okay? And
Who
they
was
made a
making their
whole
own Lisp?
yeah, it was I mean it was inspired by Common Lisp and they started doing stuff in Common Lisp, but they moved on to C. But they started it as a Lisp language for Postgres. And then they basically have a node that is basically like I don't remember, but they have like an abstraction with like cons and stuff that literally everything inside of Postgres uses that. It's like literally if you remove that, you can't remove that thing today because the entire database will crumble. Everything depends on that. So Postgres is actually a cursed Lisp machine.
That's
That's
crazy.
that's
Yes,
very
man, I can show
bad.
you the graph later. You're gonna be flabbergasted.
That's really crazy, dude.
So yeah, Lemus, actually extract variables should take an AST node
An AST node. That doesn't make any sense to me. Could you explain?
because um, what are the elements of a functor?
What are the elements of a functor? Uh, ooh, okay, I see. These elements are not funcs. They are t's. It's gonna suck, but okay. Because
No,
now we're
you
gonna
just
have to.
make
No, it will suck. You know why?
no,
Because we're gonna have to
you just
pattern
make
match all the time, dude. Again.
yeah, you just make extract variable take an AST node.
Yeah.
Okay,
So first thing we're gonna do is match a lem with. Okay, so what's the first case that we care?
declaration that's unreachable.
Okay, I'm gonna assume that A query is also unreachable.
Mm,
Here, at least. Fail with unreachable.
And isn't that like a horror story?
What? That Postgres is a cursed common Lisp?
No, it's a cursed Lisp machine. That's even worse.
Oh.
well, at least it's not J Diesel.
At least it's not what? I mean,
J Diesel.
well, Tom's a genius. Man, I love that
He,
article. Thank you.
yeah, Tom's a genius, indeed.
Um, okay,
Man,
well,
you know,
go
the
on,
the
Maggot.
bizarre part is that that is not uncommon, man. Like that sounds like a just pure fiction, but man, I can see that daily.
Tururu.
J Diesel.
Um, okay, so our functor, we need to var frequency map.
Name f elements. Oh, we're gonna call this recursively, so. Oh, well, it's already recursive because everything is a gigantic let.
Mm, okay, so we need
N variable.
to,
Go.
yeah, we need to recurse on the elements of the functor, and then we need to add up all of the occurrences of the variables that
Wait,
it gets
so
back.
the accumulator needs to happen here then.
No, actually.
We're gonna call ourselves recursively, right? With the elements, with this.
But elements is a list. The recursive call is actually a fold.
Oh, that also works actually. Okay, so let's do the functor first. So initial map uh, is gonna be
Empty.
I need to do an open. Wait a moment. Here it is. Uh, I don't think it needs to be empty though. We can put this thing in there in the beginning. No?
What do you mean?
Exactly that. We can just do add name f uh,
No,
this
actually,
thing
because
and
the
then
name f is not
variable
a
map
variable, Amos.
empty. The name f is not a var. Oh, this is the name of the functor. You're right, actually. You're very right. So this needs to be variable map empty indeed. Then we do list fold left. Well, and here's the thing. Magetta is not watching, so he's not complaining about it. But this problem of having company mode and Kofu activated at the same time is bothering me at work now. Because now I have the privilege of using
Man,
Emacs for work.
when we end this, we're gonna fix this right away. That makes me boil. Seeing you do that.
Fun. Oh wait.
So that's Magetta's boiling point. It's Corfu
Yes.
plus company.
Yes.
Elements. Okay, what should
That
be the limit of this, Marinho?
Extract variables.
That's not gonna fly.
Well, it needs to be extract variables and on the elements, and then we need to add the frequency maps. The frequency map that we got with the initial map that we have as the accumulator.
What's the type? The accumulator comes first. So fun, ECC.
Oh, we're going to need to add our own addition of multisets. That's annoying.
No, 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 it's not. We're now gonna have to do that because you're not using multisets.
We
You're
aren't?
using a map. We just need to do
Well,
an
yes.
update on the map.
No, 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 no. You need to do implement addition.
Mm. So, but that's basically looking if the thing is already, if the key is already there. If it isn't, you introduce that with frequency 1. And if it is there, you just update and you bump the value, right?
That's the case for a variable, but that's not the general case.
I don't
That's
follow.
not what you. Because here's the thing: if you have a variable, you add it to the map like +1. If it's not there, it's 0. If it's there, you just
No, it's
add
not
1.
0. It's never 0, actually. This is a frequency map. It needs to be at least 1.
Well, yes, if it's not in the map, that's 0. So if you add 1, you add it to the map with the value 1, right?
Yeah.
That's the case for a variable. That's the base case. The recursive case, and this is a fold, is actually uh, you start with an initial map which is empty. Then you have to map the extract variables to each element. Then you have to add up all the maps.
Isn't that just merge? Am I
It's
tripping?
merged with plus Lemos.
No, but yes, but I can't believe we're gonna have to implement that ourselves. Wait a moment.
There might be a merge with, but I'm not sure.
There. Mm. Oh, actually, you can do what I wanted before. There is a filter map function. Okay. Mm. There is a union. Union M1 M2 merges two maps using the comparison function. In case of conflicted bindings, M2 bindings override M1s.
Yeah, that's
Equivalent
not
to
what we
this.
want.
Yeah, no, but we want this, but allowing us to have a lambda for conflict resolution.
Yeah. Oh, there's a function called merge. What does that do?
I have another question for.
Probably does emerge.
No, wait. Can somebody help me here?
Okay.
Uh,
With
what is this? This is saying that there is another function. Oh, this is the one that we want, Marin.
Is it?
Yeah, compute some map
Compute
whose
some
case are
map?
subset.
No, we don't want a subset.
Oh, okay. No, but this has the conflict resolution. This function is similar to merge. Okay, so there is a merge here. Merge f m1 m2 computes a map whose keys is a subset of the keys of m1 and m2. The presence of each such binding and the corresponding value is determined with the function f. Wait,
Subset.
what? I don't follow what was said. Merge
That's.
f m1 m2 computes a map whose keys is a subset of keys m1 and of m2.
It should be a. It should be the union, right? Not a subset. Because this takes options.
I don't understand why this function is called merge. Can somebody explain to me?
you know what's funny? I literally said probably does emerge. I didn't do the merge.
What the heck, man?
Don't worry,
The
man. You can write it yourself.
the presence of each such binding
Oh,
and the
wait a moment.
corresponding value.
Oh no, this can work as a merge because if you pass a key and you actually receive two sums, that means that this key is a conflict between these two, right?
Yeah, this is kind of what we want, I think. I don't know why it says it's a subset, it's not.
No, it can be a subset because you can
But
receive
it's
none or
not.
in some and so on and so forth.
No, no, it would only be a subset of both of them if it only called the function to return a sum when both keys are present, which is not the case.
Disappointing.
Well, the
Uh,
function exists. That's the important part, so we can just use it.
okay. Let's let's try. So, uh, wait, but you said before we're gonna have to implement some multi-set functions, right? We need to implement that
Uh,
then.
we don't actually, because we can just use a merge for it. It's merge with a function that, well, if the function receives a sum and a none, it just returns the sum. If it returns two sums, then we need to add up the two numbers.
Okay, let's actually implement that because that sounds like a useful thing to have. Uh, so let merge
Multisets
maps
plus. It's
multi-set
multiset
plus.
because we're
Mm,
adding two multisets.
I can't do that. So we're gonna have actually we can use the other notation. It's easier in this case. Um, it needs to be the
Oh,
signature of this function.
well, it takes a function. Well, it takes two frequency maps and returns another frequency map. That's the signature.
No, then I'm not gonna do the other thing. I'm gonna do it like this. So M1 is gonna be the var frequency map. Then M2 is another var frequency map, and we're gonna
And
return the same thing.
yes,
Then we're gonna do a let with some sort of a lambda here, which will be the one that I want to copy here. Uh, but let's see. The key is a string. We know that. The a
is an int.
is an int. This is also an int, and
This is
this is
also
an
an int.
int. Then we can just say function um,
But it takes three arguments.
takes. Oh, you can only do the trick with single argument functions, right?
Yeah.
Ah, okay, Mo.
What's
Okay, Mo.
the suffering now? Let's see.
I wanted to use the syntax for like multiple pattern matching, but then Marino reminded me that you can only do that if you have arguments with functions for single arguments, like these ones.
Yeah, you can have a tuple, but
Yeah, but we
that's it.
can't control this. This is a thing that you're gonna use in a fold, well, in the merge. So the merge is
Um,
expecting this thing.
yeah,
Yeah, annoying as fuck.
yeah, you can't.
Um,
Which is a lambda, like a normal lambda.
yeah. So this is the key.
We don't care about the key actually.
That's true.
Lambda seems
Uh,
crushed today.
well, man, I'm sick and I have two jobs. I kind of
That is
like
understandable.
the. It's an evidence of love for you guys that I'm here.
And you're doing OCaml.
I like OCaml actually. After batteries, I do like OCaml. I told you this already. This is not K. This is V.
Right, let's trust humans.
Now, what is
That's
my reasoning for
V2.
lying to you?
Well,
Tell
don't
me.
know, maybe
None.
you feel like there will be some divine punishment for disliking OCaml.
No. And I did bullshit again. This. So if there is a sum with oh my fucking god, names. I'm gonna call n. Then we're gonna return what? Sum
Sum and
of
1 plus n2.
yeah. If it's none and sum and shoe, this is just sum and shoe. If it's okay, that's annoying. Not that. Sum none sum and if both of them are empty,
We return none as well. Actually, I
makes
don't think this
sense.
case is actually called, but we
No,
need it
but
for the
we
pattern matching to be
yeah we
exhaustive.
should definitely go in, and then we're gonna do the open So register map. Where is the open? There. Uh, there. Oops. And another thing, Mageta. Tomorrow, the day after tomorrow, like Sunday, my family will come in for Christmas, which means that
Mhm.
tomorrow I'm gonna have the biggest trip to the supermarket ever seen. And I have no
Perfect.
enthusiasm about that at all. So I'm happy I'm doing OCaml
I
right
don't
now.
like supermarkets as well.
Uh,
Especially now that they are probably all
my
crowded.
problem is not then. The supermarkets themselves. My problem is the fact that I'm gonna have like 3 carts of stuff.
Yes. That you need
Uh,
to go through the cashier, bring it home, pack in your car.
yes.
If you live in an apartment, it must be even worse.
Actually, my sister was mentioning that we should do 2 trips because we are afraid because we're gonna also buy meat that my mom's gonna use for cooking. We are afraid it's gonna take so much time in the supermarket that the meat will like well be burned in the sun of the car inside the car. So we are considering doing a trip. Go
That is
one
actually possible,
yeah. Uh,
especially since you live in the middle of the desert.
yeah.
The
Let's
best
call
place to build a capital of a country, by the way.
Yeah.
wow. Let's call it plus Lemos.
Sure.
That's that's kind of what it is, kinda.
Cool. So now let's go back here. Where
Why
were
don't you
we?
call it Append?
Well, you
Mapendo could
could,
also be. Yeah.
you
I'm
could.
actually gonna do that just to piss off the OCamlers. Mapend.
Actually, the entire thing is a append as well because addition of
Yes.
multisets.
Yes.
So
Actually,
that
I'm
Yeah.
was
gonna
your
thank you.
revenge.
You guys are helping me piss off
So
people.
that's your
That's it.
revenge. I
Yeah.
know. That's your revenge.
Yeah. That's cool. Okay. So where were we about to use this function? I forgot. Unlock register, generate code,
Extract. Extract.
extract. Yeah. Yeah. This thing.
There. Yeah.
Okay. So we have the initial map, we do some stuff, then we fold the elements. And what are we going to do about it? What's going to be this lambda here?
It's going to extract the variables of the E and do mappend with the
Multi
accumulator.
set mapend ACC, this thingy,
Extract variables.
extract
E.
variables on E. Yeah, it could be worse. Okay.
Multisets are amazing, Lemus.
Yeah, no, I'm getting in touch with cool data structures. Finger trees, now multisets. It's cool. Um, what
No,
about
I
the
mean
variable case?
mathematically as well. They are pretty nice. But yeah, the variable case is just the variable case is just we return a frequency map that contains just a variable with the value 1.
Mm, add. Is that not it? I'm surprised. Where is the add happening? I think
It's backwards.
register.
It's key value, I think, and then the map, I think.
Oh, key value. Okay, so I'm just stupid. I forgot the key. I need to put a 1 in there, right?
The
Extract.
key, yeah, the key is the variable name and the value is 1.
There it is. Whew. Okay. So now we need to wrap this around. So st there. We have the extracted head variables, which is cool. Then we want to pass the body, and the body has the body is already a list of funcs. We're gonna have to make a lambda because of that shit. That's cool. Okay, so here I'm actually gonna do this here. So here's gonna be
No, it's
fun acc e,
no,
then
it's just
multi set mapend acc
it's literally the same thing
ast
we have.
functor e.
No, it's extract. It's
Yeah,
actually extract
extract on top of
variables,
that actually. Extract variables.
and you don't need the ASC functor. I don't think actually.
I really do think we do need, because a body is just a func, a list of funcs. We need to transform them back to functors.
Okay.
Um, okay, so this means that we have a multi. Yeah, we have two frequency maps of the head and the body. That's it. What do we do now?
We need to treat the special case for the head and the first clause somehow.
Um, okay, so we need to do that before calling this thing, actually.
We do, yes.
Hmm. Okay, we can improve this later, but I have an idea. I do have an idea.
Write a fix me comment.
No, no, that's not gonna work. We need to pattern. My idea is to pattern match the body and see if, because if it's empty, we need to do something different, right? We need to do, maybe we should not even do this because it's just a fact if the body is empty, right?
If the body is empty, it's just a fact, yes.
So that means that all of this should happen inside this case that we know it's not empty, right?
Yes.
Yeah. So let's do that. So let's copy all of this shit. Put here.
I give up on Golang.
I'm not surprised at all. Actually, at all. Um, then we know that there is at least one element here, right, Marinho?
Yes, we do, because we already eliminated the empty case.
Mm-hmm. Yeah, so my idea is to make another fold here. Fun, ACCE, which is going to be for now exactly the same shit as this. So there, there. And instead of doing this, we're going to do this, head, and I'm going to call it as first, but I don't know what's it actually. And we also need the variable map empty. How do you construct a list of stuff, Magetta?
Constraint. Wait, what?
We will need to. I want to construct by hand a list of stuff.
Semicolon.
Okay. What's the? Okay. Oh, it's probably list dot this. It isn't. Head. It
HD.
isn't. HD.
HD.
Then here, list tail. There. TL probably.
Probably.
Yeah.
Yes, it is TL.
Regardless of how ugly it is, we can beautify it later. Does that gonna work, Marinho?
Is that gonna work? Not quite, actually, because we're still not treating... Well,
I love the long pause.
It's the loading. It's the
okay.
loading animation, dude.
Yeah.
Okay, so I have a couple questions that I'm not sure I know the answer to, which are, okay, what happens if the same variable appears twice in the same clause? Is that a problem?
Do you mean like
Like,
do you mean like father AA?
yes.
Do you mean like this shit?
Yes, like that.
That's a very good question. I have absolutely no idea. Um, I don't think the book mentions that case though. What are we gonna? We can guess about. We can guess and see what happens.
Hmm. Hmm.
Oh, there is the sequence of instructions. This is what we need to compile to, right? This thing.
Yeah.
Hmm. Yeah, but I don't think there's a case when that's happening though. And unfortunately, this is so deep into the lore that I don't think Magetta knows. Now what do we do?
What thing of the Lord?
Okay.
Oh, the book. No, I
Yeah.
haven't gone that far.
No, 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 no. But not well. It's not about going far. It's chapter 3. But do you see this thing?
Let me see. Wait. Okay.
So what we are doing is that there are special compilation rules. If the variable that is appearing on the head, it's a mess. But long story short, the appearance of the variables in the body and in the head, it matters for the compilation process. So
Okay.
far so good. But the problem is that Marinho asked, what if in the head we have variables that are appearing twice? So instead of xy, it's xx.
Mm-hmm.
What the heck should we do about that? And they have no idea. So that's the current
Does that
situation.
even make sense? I mean, it seems to me that they should be unified
They
before.
should. Yeah.
They should, but what if you are just stating this thing, like pxx, qxz,
You can just
rzy?
make a horrible decision and disallow that on the language altogether.
The problem is that to do that on the level of the compilation, that would be very bad. Like, it's gonna be a mess.
Probably it's more difficult than just doing the other thing.
Okay,
Right?
let's, Marina, I propose the following. What about we try to just don't care about it for this special case, and then we compile and see if you reach something that makes sense afterwards.
Okay. Uh.
And of course, I am assuming that you, me, and Mageta will be able to detect if it makes sense.
Okay. Well, in that case, what we need to do to treat the special case of the head and first clause is, let's assume that, yeah, let's assume that, like, if the variable appears twice in the same clause, let's just count that as, hmm,
Wait, isn't that being treated here?
not quite, because here's the thing: if a variable appears in the head and also in the clause, and it appears once in each case, that's one occurrence, because,
Ah, fuck me. I
yeah.
see. I see. So we need to. Uh, okay, so how do we plan on doing so?
Yeah, I was going to suggest before the question of what happens if there's the same variable multiple times in the same clause, I was going to suggest, okay, we actually extract them as a set and then we turn it into a multiset later when we add the multiple clauses together. But that doesn't work if it matters if a variable appears twice in the same clause, you see?
I don't know if I see, but I don't know how your first solution, your first proposal solves the problem.
Like, if the variable appearing twice in the same clause is one appearance, then we could say, okay, we extract it to a map for each clause, and then we turn that into a multiset, well, not a map, a set. Then we turn it into a multiset of multiplicity 1 for every key, and then we add all of those, and that gives us whether, that gives us the final
Oh, I
count.
see. Your solution would be to do these special case of the head and the list as
Yeah, and then
sets, combine them, and then convert that to a multi-set.
yeah, because like if
I see.
the variable appearing twice in the same clause counts as one appearance, then you can say, okay, I'm grabbing a set of
Let's assume
variables.
that though. Let's assume that if there is an XX, it's only one appearance.
Well, if that's the case, then the algorithm is a little different. Instead of extracting a multiset directly, what we do is for each clause we extract a set, not a multiset, but a normal set. Then when we add up the clauses together, like when we consider the entire predicate, then we turn the sets into multisets with count 1, and we just add them together.
Okay, I have a
And then,
question though.
okay.
Who wants to die?
should we do the extraction into a set first and then we transform to a multi-set? We only do this for the special case. We don't do this for the body.
No, 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 no. We will do this everywhere. And then the special case, the way to treat that is to say, okay, I'm actually going to extract the head and the first clause into a single set before I do the multi-set addition.
Why do we need to do that with the body though? I don't understand.
Because we are assuming that the same variable appearing twice in the same clause is one appearance.
Mm. Mm. Mhm. I think I see. So, yeah, that means that if you have an XX in the middle of the body, we need to do that strategy of the set first. Jeez, that's really annoying, dude. Okay. Uh,
Corner cases, they matter a lot when you're implementing language lemons.
set, so set
And you're
to...
doing microservices as well. The question is, can you identify the corner cases? Most of the time,
Uh,
not, because there are no corners.
okay, so this will be basically a string, yeah, a string t.
Okay, Mageta, I have a counter argument. Like, okay, how do you identify the corner cases for microservices? Well, as long as you draw every service in your diagrams as circles, then there are no corners, so there cannot possibly be corner cases.
Makes sense. If the whole principle to make that exist is already founded on the idea of physical arrangement, right? You just make an argument from physical arrangement. Done. It's actually, yeah, I mean,
do we have fold? Yeah. So then will be a
it's
lambda.
literally like people asking Bertrand Russell to prove that he was the Pope.
I see. S. Uh, let. So it first comes the element and then the accumulator. Okay, lm acc. This will be add lm 1 acc. And then in. Uh, this expression has type key, but an expression of type int something was expected. Wait, what? Am I going
Mm,
crazy? What's wrong?
key s.t int t set to
Ah,
multi-service.
fuck me. This is this thing. Okay, so the fold for sets, the container is not at the end. I'm not gonna
That's
ask for
weird.
the questions. Okay.
That's weird.
I'm not gonna ask further questions. Okay, but then that
Yeah.
means
I defeated Golang.
nice.
I
Nice.
defeated it.
Okay, what do we want to do? We want to fold. We need to change the extract variables to return sets now, right?
Uh, yes, we do.
Okay, so this will be string st. This is now completely wrong. Makes sense. I'm gonna assume though that this has a merge
I love how
Probably,
union,
it's probably called union actually.
and this is not that. And this
I
should
was
not.
thinking here, maybe one day we should make a project in Nix.
We tried. You don't remember, right?
No,
Yeah, you don't remember. It was so traumatic that you don't remember.
that makes sense actually.
Yeah.
I wonder if you can write a compiler in the Nix language.
Uh, Technically you can't spawn scripts in it.
I think me and Mageta, we tried for like 15 to 20 minutes to try to do Advent of Code 2022 in Nix.
Oh, I'm much better at Nix now. I I wouldn't try the
Okay,
advent of code,
let's see
but
if you can
I'm much
solve the
better.
problem that we couldn't last time. Can you do I/O with Nix now?
Oh man, here's the thing. You don't do IO in Nix.
Yeah, but then we came to the conclusion. Wait, are we gonna do AOC in Nix or in Bash?
Oh, like here's the thing. You can produce a derivation that has a file written with the value.
Yeah.
So that you can, but that's like literally the IO of Nix, right?
Wait, did I actually Mageta confuse me? Oh yeah, confuse me. Thank you, man. Thank you.
You're welcome. I don't know why, but
Because I
welcome.
wrote multi-service instead of multi-set.
Multi-service.
Yeah,
You're going crazy.
yeah, that. Horrendous. Okay, we need to make this lambda a better thing, dude.
Hmm. I hate
Let's
Google.
let's call this the folder.
Uh, Actually, the extracted head variables, we want that to be a set, otherwise we're not actually treating the special case correctly.
It is already a set.
Okay.
In folder. Cool. And I just noticed this special
Yeah, no,
case of the body also. Mageta, please pay attention to the chat.
Uh,
Go, Marinho.
oh, let me.
Go, Marinho, go.
extract variable set to multiset. Yeah, no, actually, we're not treating the special case correctly. Because here's the thing, we want a variable that appears in the head and the first clause to count once, right?
Yes.
The way you're doing it is you're saying, okay, I'm going to extract the variables for each element of this list, then I'm going to turn it into a multiset, and then I'm going to add it to the accumulator.
Oh, we actually need to. I see. We need to do this thing only. Actually, not even that. We need to
We
do
need to do,
this only at the end.
yeah, only at the end. We actually need to do basically a map, extract variables, and then just set union over the, like fold with set union, and then we do set to multiset at the end.
Union, and then you said map. Map on
Yeah, we
extract
do
variables.
map on extract variables on the head and the clauses, although
Boom, boom, boom.
those are not AST nodes though, so that's kind of annoying.
Those are AS. Oh, but it's easy to fix that. Just put this here. That. And what's the type of this? It's a func as well. So this is also AST functor. Okay, now we see the
And then we need,
type problems.
yeah, and then instead of just doing a set union, that's a fold with an empty set, and then doing a set union in the fold.
Do we need that though?
We do, otherwise we're
Because to me
trying
it's
to
just
turn.
from list or something. No?
No, 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 because we have a list of sets now.
That is true. So what you're saying is fold this thingy starting from this other thingy.
Yes,
The constructor AST functor expects an argument is applied to. Yeah, this doesn't work as a function. Why?
my question exactly.
Uh, okay, and then Holy fuck, look at this. Okay, we're gonna call, we need to make this as a function. So let, uh, yeah, in. And then
But
this,
that's only going to be used once, Lemus, for the head.
aren't we gonna do the same thing for the body folding?
No, because the body folding is not a special case. So we actually need to grab each set, turn it into a multi-set, and add all of them together.
Oh, so then we're gonna use this folder.
Yes.
Uh-huh. So this, um, and set and ast functor e. Okay.
And instead of using variable map.empty, you use the extracted head variable as the initial.
You could do what?
Use the extracted head variables as the initial value.
That's true, actually. So extracted head variables. Wow. Okay, so what's the type of this? It's frequency map. And what's the type of this? Frequency map. And we handled the special cases.
We handle the special cases, and then
Okay.
if we want to turn this into the scope variables, we just need to remove all the variables that have a count of 1 and turn the remaining map into a set.
Wait a moment. Repeat?
Like the scope variables is a set still, right?
Yeah.
So if we want to convert this into the scope variables, we need to remove all of the variables that only appear once,
Yes.
and the remaining map, we just take the keys and turn it into a set of keys, and that's the scope variables.
Yes. Okay. Um. Um. Okay. Let's do like this. So in, remove this in, return this, and we don't actually need. Uh, Wait.
There's the
Put
nin missing
here.
after the list fold left.
Yes, that's also correct. And you said that this is going to be the new scope variables. Yeah, and then we need to do this and we need to do the operations that you said, right?
Yeah, we need to remove all of the keys where the value is 1.
Wait, we did this for at least 10 hours and this is the first time I'm doing a pipe.
Uh,
Okay.
it's funny.
Oh, we
Uh,
have pipes. We can just
yeah.
use those instead of doing the thing that I
Wait,
suggested.
did you define the pipe yourself or did
No,
it
this
pick
is
that?
OCaml. This is not SML, Mangueta.
Wait, OCaml added this because it doesn't
Yeah.
have this.
No. As far as I can tell, this is this F# copied from OCaml.
No, absolutely not.
Pipes.
Like, man, SML people always did this, but OCaml didn't have this.
I think you're crazy. Let me double check if
No,
I'm
I'm not
crazy.
crazy.
Okay, so OCaml has this since 4.6.
4.6, exactly.
Yeah, but when
It
that
didn't
happened?
have it. Well, 4.6 is like 2000 what? Oh man, F sharp 1.0 is from like 2004, I
Okay,
think.
so OCaml 4.6 launch. This is 2017. No,
Yeah, that's very recent, man.
no, it's.
They just added it because the rich cousin had that.
Yeah, but OCaml has pipes, dude. Oh, look at it. Oh, actually, it's
Here,
wrong. It's
early
since
history of F
four.
sharp.
No, no, here,
Here.
but it's since 401 actually. So it's since four.
Well, is that 2004?
No,
I
no,
don't think
OCaml
so.
4. OCaml 4.
Yeah, exactly. OCaml, man, OCaml like started to get motion. The objective camel, right? I'm not talking about camel.
Camel
The
light.
camel. OCaml started to get seen in 2000, I think. So
Okay,
it's like,
so I found it actually. So it's since 2013.
Yeah, man, dude, F sharp has this shit since like what,
Wait, am I
2007?
saying bullshit? Yeah. No,
2007
no,
is like
it's
F
yeah,
sharp 2.0.
2013. 2013. It's even in the patch notes. I'm gonna read it for you.
Here, I
Uh,
have the paper from here. F sharp got added on the F sharp standard library, the pipe forward in 2003.
yeah, so the 2013, the notes is saying infix
Well,
application
whatever, man.
operators
Like
are
this
added to
one converting in
perversives.
SML, like people just did it on
Yeah,
SML.
but
It
here's the
wasn't just
thing.
not on the
This
standard library.
this operator came at the same time as this one. I didn't know that. Okay.
Wait, which operator?
This thing.
I mean the double at.
Yeah, this came with
Oh,
this.
which is the reverse pipe, but better.
Yeah, okay. So, anyway, F sharp can have that glory. I don't care,
Oh,
but
whatever. It's not even glories of F sharp. It's just that F sharp added that on the standard library and made that part of the syntax, right? But that was already a thing in SML. Like,
yeah. And what you said, Marin, would be equivalent of doing. Well, I think it's more readable because the pipe maintains the readability for well English users. But your way would be like bottom up, right? Using this thing. Anyway, so let's do this. So the first thing you need to do.
No, actually, it would be my suggestion would actually just be to make a list of functions and just compose them.
No, but that's pipe then. That's basically what we did in Erlang. Anyway, so you said that we need to filter stuff out. So
Yeah, we need to grab all of the variables where the count is 1 and remove it from the map.
filter. Okay, there are two filters. Let's read. Filter returns a map only values of a of m such that fa equals true remain. And this is what we want, filter v, because we want to
Uh,
remove the ones that have one.
yes.
Okay, so this is filter v, and what do? We pass a lambda that grabs a value and checks if the value is equals to 1. Yeah. Then what next?
Then we need to grab all of the keys of the map that after this filter
Yeah.
and turn it into a set.
Okay, that's the one that I don't know if we have a handy way of doing it or we're gonna have to fold it. 2. Okay, wait. Uh, let's do to sec because I believe S has from. No, this is going to. Magenta,
mhm.
what's the name of the functions that we can like convert from something else? It's not called from, isn't it?
Wait, what?
I have a list. I want to convert that to a set.
Uh-huh.
Do we have? They don't call from list, right? They call something else.
Oh, they call either from or off, depends on the
Off.
library.
Off. Aha. Okay, so it is something like this. Okay, so the keys, and keys is not liking keys. Okay, so val keys. It returns a bat enum.
Huh. No, that's not what we want actually.
Yeah, no, I got that one. Can we convert this to? Let's actually see if there are convenient functions in this. Because if there is, I can just convert it to the set. Set. No. Okay, so find map, peek, get, push. Actually, I'm gonna use LSP. I'm gonna do a Magetta move.
Thank you.
Bet enum dot off. No. 2.
Literally alleviates our brain, man.
Didn't help.
What are you looking for?
We we filtered the map uh, based on the values. Then
Mhm.
we grab the keys out of the remaining map after the filter, and now we want to get to a set. I thought wrongly that after the keys we will have a variable map, but that's not true. But this returns actually an enum, an enumeration of all the keys of the map. But that's inconvenient because we how to convert that to a list or to a set.
Wait, it returns an enum. What is an enum there?
It's it's enumeration over abstract collection of elements. Enumerations are a representation of a finite or infinite sequences of elements.
It just return. Okay, I see. It returns the list of integers
Yeah, the list of keys.
representing.
Our keys are strings, but well, whatever.
Okay,
And but we need to go to sets, and
I
I don't
still
want to
don't follow the
fold
problem.
anything. Wait, what?
I still don't follow the problem. Like,
The problem is, we after this we have a bet enum. After this pipe, we need to go to a set. So we need a transformation function that goes from enums to sets. And I don't want to do a fold.
Isn't
you
there
need to
enough
convert an
enum?
enum to a set.
Yeah. Wait, what was your question, Marinho?
Convert to a
Isn't
sequence
there
then.
isn't there enough enum in the set module?
Oh, let's see. Oh, there is actually.
There we go.
Okay.
That works.
Yeah, but
Okay.
another option would be to convert to the sequence, and then from the sequence you import on the
I
set,
don't
which probably
think
could.
enums have sequences conversion, but let me check. 2 sec.
They probably are the base, but let's see. Oh, I'm saying that they are probably the part of the. They implement the module for the sequence
Ah, okay, okay. Yeah, I would not be able to tell from a control F.
because, like for example, in F sharp it does by constraining the .NET garbage, so it's different.
Yeah.
Uh,
Yeah, but Marinho's idea of checking if there is an off enum was a great one. Thank you,
y-
Marinho. Save the
You're
day.
welcome.
Cool. So we have scoped variables. After all of this work, we have a set of strings. Cool.
wow.
Nice. Now,
Anyway, Mario, I
uh,
need your help later. But anyway,
Okay.
now, what do we need to do?
We need
What do
to
we need
add
to
it to
do?
the compiler before we do the register allocation loop.
Wait, but this is the register allocation loop for the head, right? Should we do it for the head case?
We should do it for the head and the body, yes.
Okay. Scoped variables. Wait. Oh, scope variables. Then we need now to fold this, right?
No, we
Uh,
just return the compiler in the store after we allocate the
no, 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 but this
registers.
is just for the head. We need to do the body now.
Terms. Oh, hmm.
Yeah, we need to do the body now. This is just for the head. Look.
We can probably just concatenate the body, but we need to convert it to a finger tree first.
Wait, concatenate the body in what?
Onto the list of terms that we are going to allocate.
To the list of terms that we're going to allocate.
Yeah, on line 226.
Ah, okay, so what you're saying is that we can just say let terms equals this thing and then
Actually,
quotes.
actually, we can even just do a fold. In fact, that's probably better.
Okay, let's go for it then. So what fold are you thinking about?
We're going to fold. Um, I forget what's the function that adds a value to the end of a finger tree. I think it's snock, maybe.
To the end of a finger tree.
Yeah.
That's the same as our put in the store, right?
Yeah, it's push, it's knock. Line
It's
67.
67. Yeah, it's knock. Okay. Yeah, we're doing a
Yeah,
cons
so
in here, not snock actually.
no. Foldel.
Mm-hmm.
The function is snock. The accumulator is these cons that we have on line 223. And then we add the body. Just the body, actually.
Just the body.
Because we
Oh,
already
we
added the
already have the
head.
head. Yeah, that's correct.
Actually, it can't be just knock because we need to turn the body, the clauses of the body into ast.functor first, right? So
That's
just what,
true
yeah, just
actually.
yeah, just
Map
do.
Can somebody explain to me what's the motivation of people doing CLIs in Python?
convenience for
That's
them.
convenient for who is writing,
Exactly.
Yes,
not for who is using.
Well, do you
yes,
think they care?
they
Man,
don't.
Python is a plague to humanity, man.
Thank you, Margarita.
Thank you. That's so good though. Wait. Uh,
That's not list fold left. It needs to be. Oh wait, no, it is. Never mind.
no. But it is wrong. You are right actually. This should be FT fold.
No, because we're not folding over a finger tree. We're folding over a list.
It needs to be finger tree because we have this thing, no?
No. The finger tree is the accumulator, Lemos.
Ah, okay, that makes sense.
And
This
you know
thing?
what's funny? If Python was just like hi, I could accept it more. But it is not. It is just a garbage C version that is friendly and joyful and everything will be fine. And then it's like hell. Hi at least it like has macros, like it has a consistent syntax.
This. This.
Yeah, just call this thing terms and then do register alloc loop compiler with terms, basically.
Boom.
Yeah, terms equal. Line 223.
Okay. Is that it?
I think so. Assuming that our assumption holds, then that should be it for register allocation.
I have another question. Oh man, we are so okay. I'm gonna finish the recording because this is enough and my brain is melting.
And actually for code gen as well, we already updated that, right?
Yeah.